So we want to look at how you might find the vector field if you know F. Okay? Well, you got Pi plus Qj. Let F be Pi plus Qj, right? And let V just be good old V. Okay? So the gradient is partial v with respect to x times I plus the partial of v with respect to y times j. So we have two equations for our v function. We'll assume that p and q are known. Okay? So if we know p and q, how do we get v? We just integrate p with respect to x, we get an expression for v. We integrate v with respect, or q with respect to y, we get an expression for v.
Why are they equal though? Why?
I'm getting there.
Okay.
It's a good question. I mean, that's exactly what I was going to tell you. So, you know, feather in your cap for anticipating the obvious question. Okay? Which is not that obvious. Okay. Why are they equal? When you integrate p with respect to x, you get an integration constant. And the integration constant, since everything is with respect to x, the integration constant could be any function of y. Okay? And they're equal because, I mean, from this, v has to be an integral of p with respect to x, right? And from this, v has to be an integral of q with respect to y. You know, this gives you this, and this tells you that v equals this.
Okay.
And the way you get around that is what I just said. When you integrate p with respect to x, you get an integration constant, which is a function of y. When you integrate q with respect to y, you get an integration constant, which is a function of x. Okay? Any term in p or q, well, it's a function of both variables, is locked in. But if there's a expression in v that's just a function of y, it'll come out of this interval. I'm sorry, if it's just a function of x, it'll come out of this integral as the integration constant, okay? We just need to see it. Another thing is, one of the fairly powerful techniques of differential equations does exactly the same thing. So you really want to lock this in because it'll save you time. I don't know how people come out of multivariable calculus able to do this and then can't apply it in differential equations except short-term memory. Relying on short-term memory for the test and not learning. Okay? And I've never preached anything like this before, but learn the principle. Okay? Now let's just do an example. Now, okay.